Hi, my name is Timmo. Very happy to be here. Thanks all for showing up. I'm going to talk about nerves and Erlang distribution. Who already did something with nerves? Okay, oh, that's pretty much. It's more than last year. That's great. So, how many of you are using Erlang distribution? Really connecting two nodes? Okay. Oh, that's almost equal to the amount of people that are using nerves. So I'm going to talk about clustering nerves devices using your own distribution. There are some caveats in general, which I'm going to cover. But first, I'm going to tell you how it all started. So I work at a company where I do stuff in Elixir. But when I started using nerves. In the beginning, it was just getting the LED to blink, which is really cool. But I wanted to do something more with it, but I didn't really have a production use case. So I have a brother-in-law, and it was his birthday, and he really liked beer. So I gave him homebrewing equipment. We decided to do it together, start brewing beer. Which is cool. Every good idea starts with beer, I guess. At least in my book. Some ideas are not that good the next day, but last night it seemed like a pretty good idea. So we created our first batch of beer, and brewing beer it's some things in brewing beer are kind of hard. You have to clean everything really well. You don't want any bacteria near your beer. It needs to be the right temperature. And this is only the fermenting part, which is, if you master that, then you can that's actually a requirement before you can move to the next step. So we decided we wanted to improve our setup to brew more beer, and for that we needed a fermentation chamber. So that's some isolated room where you can put your beer, where it's going to be a consistent temperature, so you get a better quality beer. So it seemed like a good use case to put an embedded device there that would read the temperature, and then when it would get too cool or too warm, it would adjust the temperature accordingly. So the thing is, creating a fermentation chamber is already, you need something that isolates really well, and there are multiple guides on the internet you can follow. But one suggestion that keeps coming up is using an old fridge. So I didn't have an old fridge. So one night, a Wednesday night actually, I remember the day of the week, because Wednesday night, I live in Amsterdam. On Wednesday night, a lot of people put their garbage on the street, and then the next morning it's being picked up. Really convenient if you have a lot of big stuff you want to get rid of. So somebody wanted to get rid of a fridge. So I was walking there with my dog, and I walk into this fridge. I'm oh, this is crazy. It all fell together. So I called my friend, or my brother-in-law, and I told him you need to come over right now. We need to pick up a fridge from the street. The condition was pretty good. So he had people over for dinner. Yeah, so they had to wait. Real story. So he came over. It was not that far away, but anyway. So we guarded the fridge, because I was with a dog, and with two people and a dog, and carrying a fridge was not that convenient. So I had to bring back my dog to the house. He guarded the fridge because we weren't sure. Maybe somebody else is gonna pick it up. Stuff like this really going quick. We picked up. I told my wife, okay, I'm gonna bring in an extra fridge. She's where are you gonna put it? I'm I don't know, but we'll find a spot. I'll make sure that it will fit. So we brought in the fridge, and then we thought, okay, we need to check if the cooling of the fridge still works, because it was put on the street, so maybe it was broken. So it wasn't, which was really good for us. And then I put it in my shed because there was place. I didn't have any power there, so that was like the next adventure. And that's really how how this all started. And we started brewing more and more beers, as you can see on the picture, and of course was getting better. So I had the fridge. I had no power. I had a Raspberry Pi, but like I only played with Blinky, so I played with Blinky again because hey, things changed. The Nerves project team is doing a great job. Like a lot of updates were coming out. Still, there are a lot of updates are coming out. Recently, a new Raspberry Pi was added to the family of Raspberry Pis, which is the 0 with wireless. It's like so tiny, I'm afraid to lose it somewhere by accident. Like every time a new device gets added, they have to do a lot of stuff, and they're really quick in getting everything ready. So yeah, I used this again to blink a LED, and that worked. And then I was gonna brew some Elixir, or brew with like using Elixir, or some combination of this to get the next beer out. So I bought like some equipment, like a relay to be able to control the fridge, to turn it on and off to cool. I have a simple temperature sensor, and I needed to heat inside because when it would get too cold, like it's in my shed is not isolated, so I needed to make sure that I could heat it. So I bought an old light bulb. They are perfect for heating. It creates some light, but you can work with that. You can shield it off your beer so it doesn't like affect the beer in any way. So the setup worked, and I had like attached two diodes to see if the bulb was on or the fridge was on. Like, you have this problem. There's a light in your fridge, and you don't really know if it turns off when you close the fridge. So I had a solution for that. I just checked, like on the outside, if the fridge was on or the bulb was on. I didn't have any clue what the temperature was because back then, Nerves networking only offered like wired connections. I put a power cable there, but I didn't have any Ethernet there because that would be too much trouble. So I would like walk all the way over to my shed, check the temperature, or to check what it's doing, and every time it seemed all right. I even sometimes when I wasn't at home, I was like, I still want to know, like, does it work? So I called my wife, like, I'm at work, called my wife, like, can you like, we just want to know what it's doing. Can you maybe like take a look and tell me what it's doing? She didn't mind. Good for me. And then I decided I want to check the temperature aside from like if it's heating or cooling, because the heating and cooling is cool, but you want to know, like, is this a steady line or am I like overshooting, undershooting, everything? So first I started just like enabling the networking part. So walking with my laptop to the shed, connecting it with UTP and logging in and seeing what's what and how it would work. That kind of worked. Luckily, soon after that, Nerves Wi-Fi. So it's still a long range, but it kind of worked. I bought a new router though, but it kind of worked. So I could enable this because like the Nerves team again did like this excellent job of adding a new feature, which made it very easy to configure your Wi-Fi and make it work. So then I did some stuff to try to see how to connect to it. So I created an SSH wrapper for Erlang SSH, so I could have the Elixir shell, because like when you're coding in Elixir, it's easier to be in the Elixir shell and not in the Erlang shell. Then I added like a simple web page, like to see like what's the temperature, what's it doing, like very simple. I created some forwarding, so I could even like log into my domain and see what my beer was doing, which for me like was a great victory. My wife liked it as well. So then I added some more networking stuff because as soon as you're connected, right, you can get all the data out of it and you can handle it somewhere else. So that's really convenient. But it's all good. But if you're thinking about Erlang distribution and fault tolerance, and you want to get like two Erlang nodes talking to each other in a fairly easy way, I think. If you're creating something on your Raspberry Pi and you want two nodes to talk to each other, you just want it to work. Like, okay, I'm gonna say this once. So if you're doing something in like IoT, you just want it like to connect and like, oh wow. So I think it's time that like this is some background where I came from and made a really good use case for me to start actually using it. And I think that's the most important reason to start, or it's the easiest reason to really start using nerves instead of doing the tutorials or the examples or basic stuff. But I was really interested in distribution, and I thought, okay, a nerves example. Hello, distribution. Come on, let's do it. So the idea was when I started trying to get it up and running, to have like a lad on one device, and when you have a lad on the second device, and when they talk to each other, you can take turns. So so that would be like a distributed blinking lad, which I coined distributed blinky because like they are taking turns. So it's very simple. I have a small like example of it, which is I hope it works. It works. So it's really not sure if everybody can see it because the LEDs are really tiny and you cannot turn off the. I will do it once more. Like it's like this one, you see, and then it's I think somewhere this one. So they are taking turns, talking to each other. Very basic strategy by using Phoenix Pops Up, which is just broadcasting like, hey, who's the next guy who wants to blink a LED? And then the next guy shows up and blinks the LED. And then he says, hey, who's the next guy? Oh, there's no next guy. Oh, then the first guy. Raspberry Pi, they're not. Sorry, I like them, so sometimes. So how did I do it? It was, if it still works, cool. How did I do it? I created a configuration. Is this readable for everyone? All right. I shortened it to make sure it would fit on a slide and wouldn't have like any. So there are some things that are missing, but you will get the general idea. So I gave each host or each nerves node basically a host ID, and I would generate like this static IP address and static node name, so I would know upfront like, oh, these are the nodes I have. And actually, the first node with like ID 2 would only know about itself, but then any higher node would know about all the previous nodes. So I would create the node name here. I create the initial nodes list and the IP address of the Ethernet interface. So those Raspberry Pis you saw were just connected like straight, but you could put it on a switch and then they would all collaborate. However, this doesn't work in every network. Definitely not on my network. It works in an isolated network. So aside from the interface configuration and the initial nodes, I templated the VM arcs that were installed on the within the nerves node. And I used name because because at the time that was the easiest way to make sure that the first part of the node name and the second part of the node name were entirely static, and we're just like, if you try to resolve an IP address to an IP address, it works. And this was templated, so I really need to make sure that during compile time, I would set the right environment variables. So every host would have its own ID and its own name. So this worked, but you cannot install a Raspberry Pi and say, here you go, it will auto-connect to whatever like nerve device you have in your room. And there are some other considerations for naming. So for naming, you have two options. The name is for fully qualified domain name, and the S name is for short names. S name you usually use to just give it a name and let the domain part be decided by the host it's being run on. So the name, technically, it should be a fully qualified domain name. So that's, I don't see it recommended ever, actually. Maybe there are like very good reasons if you have like a very specific cluster. But most of the times, people recommend short names because then it's fairly easy, and you like solve your own domain issue. But both solutions still depend on DNS, so you need to have DNS. And if your router at home supports, like when you register with DHCP, that you get a domain name assigned to your device, then it works. But still, that doesn't work in all cases. The other solution is add host to your host file, but then you need to know the IP address up front, so you rule out DHCP. So that was kind of an issue I wanted to solve, because when you're at least for like the hobbyists, when you want two nerve devices in your network, you just want them to connect. You don't want to set up DNS or whatever solution. And then there's another thing, EPMD, Erlang Port Mapper Daemon. It listens on a default port, which you can configure, by the way, and it talks to EPMD, talks to other EPMDs to get information about the nodes running on a specific host. But it's not within the Erlang VM for that reason. Multiple Erlang nodes can register to the same Erlang Port Mapper daemon, and it means you need to manage a process outside of the Erlang VM, which gets more tricky on an embedded device. And preferably you would do this in Erlang as well. And for nerves, you're only running one Erlang VM on one Raspberry Pi, so there's really no need to have EPMD or like similar tools. You can solve that in other ways. So EPMD can be replaced. You can write your own EPMD module for quite some time. I've seen various solutions. Yeah, it only returns the port that your Erlang node is running on. So for the address, or the IP address of the node, that's part of the distribution protocol, which resolves domain names to IP addresses. And that is inet TCP dist. So this is the default Erlang distribution. You can also use the SSL one if you like to have a secure connection. And I think starting with Erlang 19, you can write your own distribution module and tell Erlang to use that instead of this. And the downside of this whole DNS thing, I tried various solutions to map the DNS request to something internally, or like Erlang can do DNS via the host, like a normal call to the system, or you can do it within Erlang. There are multiple solutions. But I wanted to create a custom distribution because then I have complete flexibility of how to get the address and how to get the port and how to get all that information just based on a node name or based on like maybe a key value store I have somewhere. So you can do this by, with Erlang you can give startup arguments, so you can do this by specifying protodist, sorry, never mind. So you can do it by specifying protodist. And of course, if you're doing this with Elixir, you have to prefix the module with Elixir dot, because otherwise, that's actually all Elixir modules are in that namespace. And you need to name your module like this. I don't really know why. So the argument you give to protodist is name of module. It's really just module. And then the module is actually name of module underscore dist. So this is kind of tricky. It took me a while to figure it out. I thought, why doesn't it work? So that's kind of funny, I think. And by using this module, I could skip doing DNS requests. So that module kind of like looks like this. You get like a setup, a request from the net kernel. And I'm only doing this for short names because I wanted to have like a quick solution for my use case. And I still ask for the EPMD module. Since you're writing your own distribution module, you're writing your own EPMD module, you can just short circuit everything. But this gives me the option to have different solutions for solving ports and addresses, because I can now ask the EPMD module for the address and the port. So you have to implement a few callbacks in the EPMD module. I just think that like if I add another one, which is useful for me, I can let the EPMD module find out where the node is and connect to it. So EPMD module, you can reference it like this with startup arguments. And you also, I think, have to flag to not start EPMD. I'm not really sure, though. I haven't really tried. There's another flag called start underscore EPMD. And when you tell it to not start EPMD, it won't start by default. And there I implemented a new callback. I hope this is correct because I rewrote it this morning. I see it doesn't fit on the slide. Okay. So I extracted the actual logic here with extract IP port from the state. So let's say you would keep in your state a list of nodes that you know the address and port of. It doesn't really matter how you get that state or how you generate it or get it from some database or store. And then you return the IP port. So the distribution module knows where to connect. So I was trying to kind of make this work, but so I looked at the original Erlang in a TCP dist module to see, okay, how does it work? Where can I reuse already written code, because that's way easier. Actually, it's quite a lot you can reuse. So I only had to change a little bit. And yesterday I was able to connect two nodes, but there was some timeout going on, which was really weird. Referencing the wrong bit didn't help there. But I think I'm gonna show real quick with a bit of a hack. Unfortunately, I couldn't get my Raspberry Pi to work. Still, I'm gonna try if I can. Let me see. I'm gonna try and do a quick demo. Oh, wait. All right. Cool. All right. Maybe I should create 2 screens straight away. Oh, that's here. And I'm going to do some magic because the thing I implemented, I used multicast DNS to get 2 nodes discover each other, and then I would add them to the state of my process, and then so I'm running this locally, which is a bit sad actually, but that's the thing. Yeah, I will. Better? Whoa. Sorry, my... Okay. So I need to make sure, because there are some, you cannot use multicast DNS on a Mac because it's already in use, so you cannot listen on the same port. So I'm cheating a little bit with specifying on which ports I run, so I can let 2 nodes talk on the same machine. Now, let me see. I have this somewhere. Sorry for letting you all wait. Okay. So this should be the first node. So here you can, is it readable now? Should it be bigger? Yeah, I can make it bigger, but I'm going to show the other one as well because there will be 2 nodes. So I need to. I can, yeah, sure. I don't know what's up with this though. This is what happens when you do demos. It's not that good at it. So I have to increase this one as well. Is this readable? Twice as big, yeah, but that, I don't know. I'm sorry for the people in the back. Maybe, the thing is then it gets too small, right? All right, so I passed some extra Erlang arguments right here. It's not really important. It was in the slides. But I'm also specifying the path where the libraries are because that's necessary. I'm not starting mix here. And the modules are started by net kernel. So you don't really control when your module gets started. So you need to make sure that your code is in the path. So this is starting one node, and it crashes, of course. This is so much fun. All right. Try again. It still doesn't work? All right, cool. So I have an an EPMD MDNS module. And I need to configure the IP because usually you don't know that up front. Right now, I'm going to specify my local IP, and that works. It doesn't see any other nodes because there are not yet any other nodes. So right here, I'm going to, wait a minute. So now I need to cheat with the ports I listen on. Which I should have made configurable. I also, I thought I closed all the other. This is kind of funny. All right, this is sad. I was really hoping to show how it worked. All right, cool. Set. Oh, MDNS. Set IP. So if you're better in live demos, you should sign up for next year's ElixirConf. So now you see I set the IP. It makes a DNS request, or a multicast DNS request. It's received here, which sends a response to the other node. Multicast DNS is really not that much rocket science, but it's like pretty cool that you can set it up like this. Now I need to make sure that on the other node I should learn about. Oh, thank God! I thought it was crashing already. I need to make sure I know both nodes as well. And now if I want to connect to a node, I can just use the normal Elixir tooling like node connect, saying bar at my localhost, and it's connected. Woo. All right. How am I doing in time? Pretty good, actually. So the basics are, I created the basics. I was running into a bug where when I would enter node connect, it would just hang my entire VM. So something was off. But I'm glad it's fixed right now. I haven't been able to get my Raspberry Pi on the Wi-Fi here, which is, of course, what happens. So I'm not going to try that, because then I would stall you even longer. So let's get back to the real thing. So I would like to thank everyone. I'm gonna. So I brewed a couple of beers. I brought 2 bottles to Barcelona. 1 survived. So if you're quick after the talk, I'm like right there. We can talk about beer. You will only get a sip because there's 1 liter of beer, and please don't push people away. It's just gonna be first come, first serve. Are there any questions?
Give him another round of applause. We have a short time for questions before we'll move over to the next talk, so let's see some hands.
Hi, I have a question about timing, because
Yes.
you're using interim Wi-Fi.
Yeah.
So the IP address doesn't come up immediately. How does that work?
I register for these events you get.
With the registry process?
Yes.
Yeah, okay.
Yeah, and I haven't really been able to try to really give it a good shot, but I hope it works. maybe you know, but
Okay, I have a slightly different approach, but that could be better. And the multicast DNS, sorry, 2 questions. That's
sorry, yeah.
the multicast, that works just great, does it? Because I've tried another one before and I couldn't get it to work.
I'm sorry.
The MDNS.
Yeah.
What's the library?
It's first I was using a library written by Christopher from I think on Slack is Antone.
Okay.
From
Yeah.
Realtor. Sorry.
Yep.
But it didn't really suit because like he was doing a lot of fancy stuff, and I just needed to get this up. And I need to publish the MDNS library for this, but it's set up in a way that you're not tied to MDNS. You can use another discovery protocol on which you just expose like the right information. But
Cool.
I will publish it for sure, and then the link will wait.
Thank you.
Does it work somewhere?
All right, any more questions?
Right. So there will be. I need to like enter the repository on my slide, and then the slides will be shared. Otherwise, you can also send me an email or on Twitter.
No more questions? Nobody, all right. As we all know, live coding demonstrations often make excellent case studies of Murphy's Law, so
Yes.
it takes a very brave person to give one. So give them one last round of applause.